As you know, in the last period, we have seen the compound pendulum, isn't it? That compound pendulum is nothing but it is the another type of pendulum which is used to determine the value of g, that is acceleration due to gravity. The basic difference between the compound pendulum and simple pendulum was that in case of simple pendulum there is a thread, and to the one end of the thread a bob is attached, and one end of the thread is suspended to the rigid support, and that thread along with that bob it is oscillating on the both side of the mean position. That is the simplest and easier method to determine the value of g, isn't it? But the value of g, that is acceleration due to gravity, which is calculated or which is determined by using the simple pendulum, has some defects or has some drawbacks, because in the simple pendulum or in the calculation of the simple pendulum there are some drawbacks, and which are these drawbacks we have already seen in the last period. And therefore the value of g that has been determined by using simple pendulum has some defects or it is not a correct value, and therefore in order to obtain the correct value of g, instead of using the simple pendulum, another form of the pendulum that is called as the compound pendulum is used, and that pendulum is called as compound pendulum. Sometimes it is also called as physical pendulum. And in case of the compound pendulum there is a entire body, instead of a bob or a rod there is a uniform solid body, and this body is capable of oscillating freely about a point or in a horizontal axis about a point passing through its center, and that is called as the compound pendulum. And that compound pendulum behaves or it performs the simple harmonic motion, and the simple harmonic motion at the compound pendulum perform, its time period is given by t is equals to 2 pi under root L upon g, that we have seen in the last period. Now there are many examples of the compound pendulum. Bar pendulum is the example of the compound pendulum. Cater's pendulum is also the example of the compound pendulum, isn't it? But out of these two or many of the examples of the compound pendulum, one type of pendulum or one type of the compound pendulum that is allotted in our syllabus, that is the Cater's pendulum. This Cater's pendulum is in for theory also, and as well as we are going to perform the practical. As far as the practical is concerned, your paper number 3 is concerned, that practical we are going to perform very soon. So now here today I am interested to share with you about the Cater's pendulum, and then at the completion of the explanation of the Cater's pendulum I will also share or run a video in which there is an experiment, that how the experiment of the Cater's pendulum it is to be performed in the lab. So let me explain first that what we are going to see here first, and then we will see about the video. Now Cater's pendulum. Cater's pendulum, it is nothing but it is the one form of compound pendulum, isn't it? It is of this type. Can you see my slide please? This is a long uniform rod. इस तरह का रहता है Cater's pendulum, एक rod रहता है ऐसा, metal का rod रहेगा. There is a long uniform rod having the knife edges. Along the length of the rod there are two types of weights, wooden weights and metal weights. This one, यानी कि rod के ऊपर screw की मदद से दो weight लगाए जाएंगे like this. These weights can move along the length of the Cater's pendulum, isn't it? Then there are the two keys K1 and K2 of this type. With the help of these keys, Cater's pendulum can be suspended to the rigid support. यानी कि कील की मदद से उसे लटका दिया जाएगा ऐसा कुलाबे से, isn't it? And when it is suspended about the K1, then it will be moved along the K2. Therefore, this K1 is called as center of suspension and K2 is called as the center of oscillation, isn't it? Can you see? And then it is suspended about this one. Oscillations are given and time period is calculated. So first of all, I will explain that what is the Cater's pendulum. Cater's pendulum is a compound pendulum in form of a long rod having two knife edges K1 and K2 fixed near the ends facing each other but lying on the opposite sides of the center of gravity. Where is center of gravity? Center of gravity is in between. And here this is the center of suspension. This is the center of oscillation. Center of gravity is in between. And there is a metal weight, capital M. These are the two metal weights. One is here, another is here. There are the two wooden weights. One is outside, other is to the round side. Isn't it? There are the two weights. One it is metal weights, another are the wooden weights. Metal weights are having the weight capital M. Wooden weights are having the weight small m. Isn't it? So these are the two knife edges K1 and K2 fixed near the ends, facing each other, lying on the opposite side of the center of gravity. The position of center of gravity of the bar can be altered by shifting the weights capital M, that is wooden weight and metal weights up and downward. यानी इस तरह से वर्जन को खोल के ऊपर नीचे कर सकते हैं, जैसा हम स्विचिंग करते रेडियो की, isn't it? Which can be slide fixed on any point. The smaller weight M having the micrometer screw arrangement is used for the fine adjustment of the final position of gravity. The center of gravity lies symmetrically between K1 and K2 due to the weight fixed at the one end. And now the Ketter's pendulum is now used as a compound pendulum, and such a pendulum it is then suspended. Its oscillations are given. These oscillations are simple harmonic in motion. Therefore, as the motion of the compound pendulum, as the motion of this Ketter's pendulum, it is a simple harmonic in nature, then automatically we know its time period is given by T is equals to 2 pi under root L upon G, where capital L is what? Length of the pendulum, and G is the acceleration due to gravity, and this is the time period you have taken for the given number of oscillations. अगर हम इसको यहाँ से G के लिए वैल्यू निकालना चाहें तो कितनी आएंगी? इसको स्क्वायर करेंगे, T square is equal to 4 pi square L upon G. Therefore, expression for G it is equal to 4 pi square upon 4 pi L square into this T square. This is the required expression for the acceleration due to gravity. But one of the most important thing in this case is that when you have suspended the pendulum about K1 and you have given the time, you have calculated the time for the 10 oscillations. Then you will invert the pendulum. Now this time K2 will become the center of suspension and K1 become the center of oscillation. Again give the oscillations, measure the time for 10 oscillations. Now for this time, when you have suspended the pendulum about K2 and time period is measured, the time should be equal to that of previous one. यानी कि अगर उर्दू में अगर बोलने का है तो पहले K1 के अतराफ लटकाने का 10 ऑसिलेशन के वास्ते टाइम लेने का, उसको मेजर कर दिए, मिसाल के तौर पर 54 सेकंड है, फिर उसको निकालने का, उल्टा करने का, इन्वर्ट करने का, K2 के अतराफ लगाने का, फिर 10 ऑसिलेशन के वास्ते टाइम पीरियड निकालने का, और अगर वो भी अगर 54 सेकंड रहा या 52 सेकंड रहा तो वहां तक भी ठीक है. यानी कि वी कैन से दैट द सेंटर ऑफ सस्पेंशन and center of oscillations are interchangeable, because from previous article we have seen if the time period of the pendulum about both K1 and K2 if it is same or nearly same, then we can say that center of suspension become the center of oscillation and center of oscillation become the center of suspension. That means the interchangeability of compound pendulum, this law is applicable. But it is not necessary that every time the time period about the K1 and K2 it is same. When we suspended the pendulum about K1 and measured the time period, it shows suppose 54 seconds. And when you invert the pendulum and suspended about K2, and when you measure the time period and it is found to be 45 seconds, then there is a large difference of 9 to 10 seconds. That means center of suspension and center of oscillations are not interchangeable, and center of gravity is not between K1 and K2. That's why in the experiment, most important thing is that we have to arrange such a position of the Ketter's pendulum that the time period about K1 and K2 should be the same. यानी कि हमारे को उस वक्त तक ये एक्सपेरिमेंट करते रहने का, वो एक K1 के अतराफ लटकाने का टाइम पीरियड लेने का, फिर K2 के अतराफ लटकाने का टाइम पीरियड लेने का. कब तक ऐसा करने का? जब तक के दोनों के अतराफ टाइम बराबर नहीं आ जाता, 54 सेकंड नहीं आ जाता. अगर टाइम पीरियड अगर बराबर आ गया तो इसका ये मतलब होगा कि सेंटर ऑफ ग्रेविटी K1 और K2 के बीच में है, और उसके बाद फिर हम लेंथ ऑफ द पेंडुलम कैलकुलेट कर सकते हैं, एंड देन बाय यूजिंग दिस आवर फार्मूला वी कैन डिटरमिन द वैल्यू ऑफ G. एंड इन ऑर्डर सपोज in the first time, second time, third time, if time difference is more than 2 seconds, मतलब 54 सेकंड इधर का आ रहा, उधर का 50 सेकंड आ रहा, या 45 सेकंड आ रहा, तो इसका ये मतलब हो गया कि K1 K2 के बीच में सेंटर ऑफ ग्रेविटी नहीं है, लिहाजा आपको एडजस्ट करने का. तो एडजस्ट कैसा करने का? When the time difference is more, then what we have to do? we have to arrange the weight, वुडन वेट और जो वुडन वेट और मेटल वेट जो है उनको ऐसा खोलने का स्क्रीन से ऊपर नीचे करने का, फिर जो है तो K1 और K2 की तरफ टाइम पीरियड लेने का, फिर देखने का कि बराबर है क्या। तो ये ऐसा वजन नीचे ऊपर कब तक करते, थोड़ा सा वजन ऊपर ले जाने का, फिर थोड़ा या फिर नीचे लाने का, ऊपर ले जाने का कि नीचे लाने का, that will depends upon the difference of time period about K1 and K2. If there is a more difference between time period T1 and T2, then you have to disturb the मेटल वेट्स, बड़े वेट्स को नीचे या ऊपर ले जाके, जैसा हम रेडियो की फ्रीक्वेंसी कैसा ऐसा एडजस्ट करके जो है तो खबरें लगाते हैं या क्रिकेट की कमेंट्री लगाते हैं या कोई और न्यूज देखना चाहते हैं, isn't it? तो इन द सिमिलर मैनर एज वी आर यूजिंग द tuning of the radio at the time of making the station at the proper frequency, in the similar manner we have to move the weights up or down depending upon the situation, and we have to repeat the experiment again and again till the time period about of the pendulum about K1 and K2 it is same. कब तक ऐसा करते रहने का, जब तक K1 और K2 के तरफ टाइम पीरियड बराबर नहीं आ जाता. Once the time period has come exactly same, then we will consider that G, that is center of gravity, capital G, center of gravity is between K1 and K2. Then we will measure the distance of the first knife edge from the center of gravity, that is called as small n1. Then we will measure the distance of the knife edge K2 from the center of gravity, that is capital small L2, and that L1 plus L2 is equals to capital L, and that capital value we will put in this particular formula, and we can determine the value of G. But this method of taking the time period same about K1 and K2, it is a cumbersome one. It will take the more time. कब तक ऐसा करते रहेंगे? समझो आपको पूरे वेट डिस्टर्ब करके दिए, एक ही साइड में पूरे वेट करके दिए, तो हर एक को आपको वेट को लगाना है सेंटर ऑफ ग्रेविटी के बीच में, ऊपर एक वुडन वेट मेटल वेट एक की, फिर नीचे के दूसरे बाजू से एक वुडन वेट एक मेटल वेट की, फिर उसकी रीडिंग लेना है पहले की तरफ लटका के, फिर इन्वर्ट करना दूसरे की तरफ से। कब तक ऐसा करते जाने का? जब तक के दोनों की तरफ टाइम पीरियड बराबर नहीं आ जाता. So it will take the long time, isn't it? And therefore, in order to make the time save, in order to avoid the confusion or tedious work, or in order to avoid the bulk work, the scientist Bessel has given an accurate determination of G that does not require the tedious process of making the two periods same exactly. यानी कि ये ज्यादा बुल वर्क अवॉइड करने के वास्ते बेसल्स नाम साइंटिस्ट ने एक तरीका बताया कि दोनों के अतराफ टाइम पीरियड करीब करीब किस तरह से नहीं भी आया तो कैसा जो है तो आप T1 और T2 को ले सकते हैं. मैथमेटिकल that is the theoretical formula has been given by the scientist Bessel, and for that one he has given that the time period about the first knife edge K1 it is suppose T1, time period about the second knife edge is suppose T2, isn't it? And these two represent the equal periods about the axis of suspension. Suppose small n1 and small l2 represent the distances of the two axes of suspension from center of gravity of the pendulum. And then instead of using that formula t is equals to 2 pi under root L upon G, then Bessels have given this formula that for the time period about the first knife edge K1, that is T1, it should be equal to 2 pi under root L square plus K square upon L1 into G, where L1 is what? Distance of the center of gravity from the first knife edge, that is center of suspension. K is the radius of gyration. What is radius of gyration? I have already told you in the previous lecture. Then similarly, the same time period for the another knife edge, that is K2, that is 2 pi under root L2 square upon plus K2 square upon L2G. Then solve these two equations. That means square these two equations, take to solve. Then from that one we will get L1G T1 square is equals to 4 pi square L1 square plus K square. That means squaring these two equations, T1 square करेंगे, T2 square करेंगे, दोनों को solve करेंगे, so we will get the such type of equation, isn't it? Then after getting this equation, we will again solve it and obtain the value for G. And when we'll solve it, the practical formula, instead of this formula, T is equals to 2 pi 4 pi square L upon T square, we will get this formula. What is this? 4 pi square upon G is equals to L1 T square minus L2 T2 square upon L1 minus L1 square minus L2 square. Again, we will solve it by making this as a LCM denominator. Zuzaf Yakal you can call in Urdu. Then we will get this such type of formula. And using this formula, practically, we can determine the value of G, that is acceleration due to gravity in the experiment. The same experiment which I have theoretically explained here, same experiment you are going to perform in the lab. Because if you see the list of the practicals which are available in this first semester to our BSc first year allotted syllabus, the first experiment is the Cater's pendulum. Cater's pendulum अवेलेबल है K1 के अतराफ लटकाने का, टाइम पीरियड लेने का 10 ऑसिलेशन के वास्ते, K2 के अतराफ लटकाने का 10 ऑसिलेशन के वास्ते टाइम पीरियड लेने का। अगर दोनों के अतराफ टाइम पीरियड बराबर आ गया तो सेंटर ऑफ ग्रेविटी से K1 का फासला लेने का, K2 का फासला लेने का, दोनों को ऐड करने का। लेकिन अगर K1 और K2 के अतराफ टाइम पीरियड में बहुत फर्क है तो फिर वेट्स एडजस्ट करने के, नीचे ऊपर किस तरह से वुडन वेट और मेटल वेट जो कैटर्स पेंडुलम पे लगे हुए हैं, इस फिगर में हमने आपको बताए, इन दिस फिगर। एंड ऐसा कब तक करते रहने का, वेट नीचे ऊपर हर वक्त K1 K2 के अतराफ टाइम पीरियड लेते रहने का। कब तक ऐसा करने का, प्लीज टेल मी। जब तक टाइम पीरियड, मसीरा, जब तक टाइम पीरियड सेम नहीं हो जाता। एंड जब टाइम पीरियड सेम हो जाएगा उस वक्त K1 और K2 से L1 और L2 का डिस्टेंस, यानी कि सेंटर ऑफ ग्रेविटी से K1 का डिस्टेंस, दैट विल बी कॉल्ड एज L1, center of gravity से K2 का distance, that will be called as L2, then we will make L1 plus L2. But according to the scientist Bessel, it is very tedious. Tedious means time taken, time consume करने वाला, या बहुत difficult है कि दोनों के अतराफ टाइम पीरियड, क्योंकि प्रैक्टिकल एरर्स रहते, बहुत टाइम लग जाएगा, घंटों, 2-3 दिन तक अपन अगर समझो एडजस्ट करते गए, टाइम पीरियड एग्जैक्ट बराबर नहीं आया तो फिर क्या करना, टाइम पीरियड बराबर नहीं आया तो एक्सपेरिमेंट छोड़ देना क्या, या फिर उसको लेके आके बढ़ के जो शुरू करना 2 बजे से तो रात के 3 बजे तक, नॉट। So then what is they say, if the time period is nearly same, then calculate the time period T1 about K1, measure the time period T2 about K2, then add these to one, take the length of the first center of suspension from the center of gravity, that is L1, distance of the center of oscillation from the center of gravity, that is L2, and make the use of this formula which the Bessel has given to us, that is formula number 3 or expression number 3 here. And by using this formula we can determine practically the value of G, that is acceleration due to gravity, because the ultimate aim of this Cater's pendulum is to determine the value of G. Because in the previous experiment, in the case of simple pendulum also, we have calculated the value of G, but the value of G that has been calculated by using the simple pendulum has some defects, and therefore in order to avoid this defect, in order to avoid this conspiracy, in order to avoid these drawbacks in the value of G by calculated by using or measured by using the simple pendulum, the compound pendulum, and that is particularly the Cater's pendulum has come into the existence, and therefore by using the value, by using this Cater's pendulum we can determine the value of G more easily or more correct, not 100% correct but more correct than simple pendulum. Isn't it? Have you got this one? The same experiment I have repeated to you. So what I will do, I will try to run an experimental result for this one, a video that how the experiment it is to be performed. Now you are requested to keep with me. I will try to run this video with you. Please share this one.
An experiment for determining the value of acceleration due to gravity using Cater's pendulum. This experiment is a little bit tricky, so just keep patience, and I'm sure after 5 minutes you will be able to perform it by your own. Cater's pendulum is a compound pendulum. This is not a simple pendulum. If you want to know more about compound pendulum, then please check my video on bar pendulum. For calculating the acceleration due to gravity by Cater's pendulum, we need a Cater's pendulum, a telescope, a meter rod, and a stopwatch. So, initially, we will set up the Cater's pendulum for our measurement. In the step 1, take the metal rod and balance the metal rod on a wedge and find its center point. Now, put a metallic ring W at its center and make it tight. After that, in step 2, you need to put two knife edges K1 and K2 at both of its ends. Now, we have moved to step 3. In this step, you have two identical cylinders. One is made up of metal and the other is made up of wood. So, you put them on the rod as well, and you can see their arrangements in the figure. Now, we have moved to step 4. Adjust W1 and W2 in such a way such that each of it is 5 centimeter away from the end. After that, the knife edge K1 and K2 are just below it at an approximate difference of 2 centimeter. This is the first arrangement with which you can start this experiment. Now you can hang this Cater's pendulum on a rigid support and observe the time for 10 oscillations. So first of all, keep the metal cylinder upside and wooden cylinder downside and take the reading of 10 oscillations. Call it as T1. Now turn this Cater's pendulum upside down when the wooden cylinder is upside
It
and
is
metal
inverted.
cylinder is downside. Take this time of 10 oscillations as T2. Now you can divide this time by 10 and get the time for one oscillation. So in this way, you can get another quantity T1 and T2 as the time period of one oscillation. The main requirement in this experiment is that the difference between time t1 and t2 should be less than 1 second so that we get some accurate values of acceleration due to gravity. But this arrangement can give you a higher value such that the difference between T1 and T2 is large. In that case, you can shift knife K1 and K2 towards the center about 1 centimeter. Now, note down the time for 10 oscillations each side again and then calculate the time of one oscillation T1 and T2. Now again, you can note down the difference between these times T1 and T2. If it is less than 1 second, then it is fine. Otherwise, you can shift the knife edge K1 and K2 further to reduce this time. Finally, you will reach to a state where the time difference between T1 and T2 is of around 1 second. Now, you can slightly adjust this ring W to get this difference close to 0.5 seconds. This step is optional. The lower value of this time difference will increase the accuracy of this measurement. Now, when you have achieved the arrangement in which the time difference is of half second, now you can note down the time for 50 oscillations for both sides and then make a table. Now, you can write all these values in
This is
this table.
observation
Just
table.
take an example. Like in case of arrangement 1, we started this experiment with 10 oscillations and noted its time period and then calculated the time for one oscillation in both cases, and then the difference of their time is, let us consider, was 2 seconds. Then we arranged it further and got this difference to be around 1.5 seconds. Similarly, for the next arrangement we got it around 1 second, and then after doing nth arrangement we got a time difference of 0.5 seconds, which is ideal for our experiment. Now, after getting this arrangement, we are increasing the number of oscillations for more accuracy. So now we are oscillating the scatter pendulum for 50 times at both sides and then calculate the time period of one oscillation in both cases. So in this way, you can make this table containing the readings of Cater's pendulum. Just keep in mind that this final value T1 and T2 will be used in our formula to get the value of acceleration due to gravity. Now, take this Cater's pendulum out from its stand and balance it on a wedge. By balancing, you will get its center of gravity. Now, you can measure the distance L1 and L2, which is the distance between center of gravity and edge of knife K1, and L2 is the difference between center of gravity and edge of knife K2. Now you have got the values of T1, T2, L1 and L2. You can put these values in this given formula and get the value of acceleration due to gravity. I have also written all these points on this single sheet. You can use these points and start your experiment. Hope you liked it.
So have you got, please? Manasi, now this time your
Yes, sir.
mic is working. I think you have got this video also.
Yes.
Initially, I have
Yes, sir.
explained theoretically by myself by using this PPT, isn't it? By using
Yes,
this
sir.
PPT, I have already explained this one, isn't it? This is our experiment that,
Yes, sir.
that we are going to see in this class. Now, one more thing, that this experiment, that is the Cater's pendulum, in which we are going to determine the value of G. It is for our practical also. In the lab we are going to perform, so it is most easy for us to perform this one, and with this one, this our first chapter is over. Now anybody of you is having any question? Now